Hello everyone. So today we're going to go over our exponents and exponential functions practice test. All right, so let's go ahead and take care of this. 5 squared times 5 cubed. Properties of exponents say we do 2 plus 3 when they have the same base. 5 to the 5th power. Now, I would have accepted this answer. Box it. If you went further, great. 5 times 5 times 5 times 5 times 5. It's a huge number. Number 2. 2/7 over 2/5. I'm sorry, 2 to the 7th power over 2 to the 5th power. When they have the same base, you have 2. It's division now, so we do 7 minus 5. 7 minus 5 is 2. This is an easy one to simplify further. 2 squared is 4. Okay? Make sure to separate these. 3 to the 3rd power to the 4th. When you have these like this, when you have an exponent that's raised to another exponent, you multiply here. So you should have 3 to the 3rd times 4, which is 3 to the 12th. Four times 5 squared, according to the table you have, is 4 squared times 5 squared. I guess you can go further. 16 times 25. So I would have took this answer here. But if you went further, again, good job. And the last one here. We'll do it over here. 6 over 4. You could have just done, you distribute the exponent over 4. That would have been good enough. I would have took that. You could have also simplified this and gotten 3 over 2, which would have given you 3 cubed over 2 cubed, which is 9, 27 over 8. But this is good enough. Okay? So moving on to number 6. Given the exponential, let me go and recap again, 1 through 5. So for problems 1 through 5, you were given a table, and if not, you can Google search a table. Properties of exponents. And it'll literally break down how to do each and every one of these. It won't do numbers usually. What it'll do is it'll have letters, but you can fill in the numbers, and there's numerical examples as well. So if you're having trouble with 1 through 5, I highly suggest you look up properties of exponents. Okay? Since I'm letting you use your notes, you can easily just write them down. But just make sure you are understanding how to use them. Number 6. Given the exponential function, f of x equals 5 to the x, rewrite the following exponential function with the new given translations. So I'm not asking you to graph these. I'm asking you to go ahead and translate them. Translate means to shift them. So this is our base function right here. We're always going to have that. We're just going to be modifying that. Translate the function up 8 units. So up, we're going to do this. F of x equals 5x, because that's our base function. And we're going up 8 units, so we're going to add 8. Add 8 will shift it up. And you can check this on Desmos just to confirm. Translate the function down 4 units. So ask yourself, if up 8 units was plus 8, what do you think down 4 units is going to be? Yeah, it's going to be minus 4. 5x minus 4. Okay? So this is taking our function here, 5x, it's graphing that, and it's just shifting it down 4 units on the coordinate plane. Translate the function 5 units to the right and to the left. Now a little side note. The way these are going to work is like this. Let's say you're given a function, f of x equals, I don't know, a to the x plus some number c. So when you're adding some number c, what that's going to do, it's going to shift your function to the negative side. So think opposites. If it's plus, we're going to the left towards the negative side. Or negative, here's the positive. Vice versa, if you have f of x equals some number a to the x minus c, if plus c shifted it to the negative side, what do you think minus c is going to do? Shift it to the positive side. There you go. Okay, so knowing that, change colors. C, translate the function 5 units to the right. Again, we're going to take our function, f of x equals 5. Now let's look here. To the right. This is going to the left. This is going to the right. So it's going to look something like this. X minus, and there's 5. Go ahead and add parentheses around it, just in case. Translate the function 10 units to the left. F of x equals our function 5, parentheses, x, let me see, to the left was this way. Whoops, what did I do? And that was plus, right? Yep. So we do plus 10. And if you notice, these questions are opposite of each other. So if I went to the right 5 units and I did a minus for the right, left would be plus. And basically, this is a good little reference point right here. Okay? And this is horizontal translations, in case you want to look that up. Horizontal translations. And we do exponential. Exponential horizontal translation. I did give you work and notes for that. So you're welcome to check the slides that you've been given and the notes and stuff. Okay? Reflect the function about the x-axis. So when you see these problems on reflection and you're like, what do I do? Okay, here's what you do. I'm going to change color again. I'll go back there. I'll do that one. You've already done this, right? And translating the function up 8 units, we know was plus. You already did this, translated the function down 4 units, and you know it was the minus. You did this, it was doing a minus to go to the right, doing a minus in the exponential next to the exponent. So I'm basically crossing out everything we've done. Translate the function 10 units to the left, down here. So what we haven't done is any kind of like adding a negative or positive, right? So we've done all these, and we know we're going to do something new for E and for F. So what I recommend you do is go to Desmos, play around with it. So let's go ahead and enter our function. 5 where's exponent? Five to the x. There's our exponential right there, right? Simple. So let's go ahead and move something around. Let's add a negative to that x. Because if it's not positive, it's negative, right? Whoa, what did it do? Let's go back. I'm going to add the negative again. It basically flipped it. If you can see, it's going this way now. It used to go this way. So your question has to be now is, see, I'm just adding and subtracting a negative to the exponent. And if you can tell, it's flipping about the y-axis. It's flipping about this, right there. The y-axis, it's going back and forth across that. So we know now that if we add a negative to the exponent, it'll flip about the x-axis. Let's go back to our test. So reflect about the y-axis. We just did that one right here. We know that's going to be f of x equals 5x, and we just add that negative. Cool. So we still need this one. Reflect about the x-axis. Okay, let's go back. So when we added the minus here, that's what we got. Now let's just add it here. See that? And those are the only places you can really add a negative. See? And just like before, it's flipping about the x-axis right here. That's what it's going, it's being flipped like a mirror. Okay? So we know that we can take our base function again. F of x equals negative 5 to the x power. Okay, identify the common ratio. Move this closer. Identify the common ratio. Well, if our function here is f of x equals 5 to the x power, we were taught that f of x equals some number a times b to the x power, where a is our y-intercept. In this case, we have nothing, right? But let's go ahead, because there's no number right here, right? Oh, there's a 1, right? But let's go ahead and add 0, because in a y-intercept is always going to be 0, comma, some number, right, where it crosses. But x is always 0 in the y-intercept. So let's go ahead and plug in 0 just to see what happens. F of 0 equals 5 to the 0 power. Anything to the 0 power is 1. So when f of x is 0, when x is 0, y is 1 is basically what it's saying. And if you go back to decimals again, let me change that. Check it out. It crosses right at 1. You can also see it there too. So identify the y-intercept. 0, 1 is a good answer. Or just, I even would have took 1. Last one, common ratio is always b. Is always the term with the x, with the exponential. So in this case, our common ratio is 5. Okay? And again, just in case you forgot, common ratio is what the graph is growing by. Well, we know that when x is 0, that's 1. We do times 5, times 5, and so forth. Keeps getting multiplied by 5. These are a common ratio right here. And just to give it a quick check, at 0, we should have 5. At 0, we have 1, sorry. But then at 1, we have 5 right there. All right. So hopefully I was able to break some things down here. Let me know if you have any questions or if you want a copy of this practice test again. I can do all that. All right. See you later. Peace.